Just a couple reminders. Remember, your sub test 2 is going to be due on the night of the 29th. So it's a Sunday. So I want you to get it done, excuse me, sometime this week. And then on top of that, you have your assignments that we're going to be doing in class. So the reason why I'm doing it this way is because on test 2, you are going to take a test on my math lab, and it will include chapter 5. So I want to make sure that you turn in this subtest so that we can, fix anything that needs to be fixed before you take the other test. And I think what I'm going to do is this subtest won't have as much weight. So what I'm going to do is I'm going to average the 2 tests, but instead of equal weights, the My Math Lab test will weigh more because there's more on it. So it'll probably be like a 60-40 type of thing. So the subtest 2 will be 40%, and then the test on My Math Lab will be 60% of the overall grade. So that's how I'm going to do it. Because I don't want this subtest to ruin your test grade, because I want it to be used as a learning experience with it. Okay, so any questions on the subtest? I'm sorry, what?
Is the subtest the one that you're talking about for this week, right?
Yes, so it opened Sunday the 22nd at 6 a.m. and it closes Sunday the 29th at 11:59 p.m. So I wanted to make sure that you get that. And I would say just get it done. Get it done as quickly as you can. It's only those 4 sections of the graphing, shading. There's 4 questions. Each question is worth 5 points. So you can, kind of go from there. But make sure that you show me everything. Like if you find a corner point and you had to do elimination to do it, I want to see the elimination. So make sure you put that work on there. What I've had in the past are students who use a graphing calculator, and they just click on the button and it tells them what the corner point is, and they just put it in there. So I want to see mathematically how you found the corner points. Okay. Any other questions on that?
The actual test for test 2, that's this week, right? On Thursday or next week?
No, let me double check. The actual My Math Lab
like the actual
isn't due. Yeah, the actual one isn't due, or we're doing it Thursday, November 2nd.
Okay.
So we'll do it like we did the first one, where you come in, you have your cameras on, you take your test, and then you upload your work.
Okay.
Okay. And then that day will be a wash. I can't believe it's almost November. You guys realize we have like 7 weeks left? It's crazy. So the week of Thanksgiving is coming up. And I know like the public schools, they have like the whole week off. We do not. That's why we get out probably 2 weeks before any of the other public schools get out, because we don't take hardly any holidays. So Thanksgiving is going to be November 23rd is a Thursday. So we will not be meeting on Thanksgiving. You guys have things to do. So Thanksgiving Day, we will not meet, but we will meet Tuesday, the 21st. So we'll have just one class that week of Thanksgiving. So make sure, even if if you're going to travel, just make sure that you're available to do your Zoom class that week. And the last day to withdraw is Friday, November 17th. So that's coming up. So just kind of start thinking about, the options in your Canvas gradebook. There's a what if application. So you can put grades in for your tests, like what if grades, to see what you need in order to be in the 70s or above. So it kind of gives you an idea, a goal to work towards, and you can put in all the test grades and all the final exam grade, and that will give you a really good idea of what you need to do to make sure that you're in the 70s or above. What I have found is the final. I can't believe we're talking about the final already. The final's worth 20% of your grade. And so, and I think I've said this before, if you're on the edge, like if you're in the low 70s going into the final, there is a chance that you could drop your grade. It will either drop a grade by a half a grade or it will raise a grade by a half a grade. So if you're in the low 70s and you do really poorly on the final, you can get dropped into the D range. So just be aware of that. That's a little pressure to put on you. That's why I always say make sure that you have as high a grade as you possibly can have going into the final. If you're in the mid to high 80s and you do really, really bad on the final, you can still get a C. So if you can get your grade into the 80s, mid, 85 or above, going into the final, you'll be fine going into the final. Kind of the pressure is taken off. You still want to do well on the final, don't get me wrong, but you can kind of relax a little bit about the final. But if you're in the low 70s or even the high 60s, I would push as hard as you can right now to make sure that every test grade is perfect, or at least close to perfect. Every homework grade is perfect and every quiz grade is perfect. And remember, you have 2 attempts on the quizzes. And 99% of the time, if you do the quiz the second time and you've taken the proper steps to figure out what you did wrong the first time, you will improve your grade. It always improves the grade. So I have not had a chance this morning to go get or to look over the homework that was due last night. But I'll get to it. I will get to it. So I haven't even seen who's turned their stuff in and who hasn't. So I can't give you a hard time today. So. Okay. So any questions about the final? Any questions about the upcoming tests?
I have a question actually.
Sure.
It was based on the quiz we had yesterday, this number 7.
Okay.
So
Can you meet me after class? Just
Okay,
stay
yeah.
after class for like 5 minutes and we can go over that particular one.
Okay, it's just
Okay.
I wasn't able to see like the grade. Like I wasn't able to see it inside the classroom,
In the Canvas grade yet?
Not the grade. I mean like actually see the questions.
Oh, okay. We'll have to take a look at that and see what's going on with that. So, but yeah, let's do it right after class and then we can go from there. Now we can look at that one in particular. Okay, so what we're doing today. So this week we are looking at factoring, and factoring is one of those topics that a lot of students are either you're really, really, really good at it and you just get it, or you really struggle with it. And so with factoring, the reason why it's a little more difficult than for some is because you have to be able to recognize what kind of factoring you're doing. There's actually 6 different types of factoring, and then one just prime where you can't factor it. And what I wanted to show you real quick is where are we going with this? So sometimes it's nice to be able to see, why am I doing this? What's the purpose in factoring? So when you're factoring, what you're doing, I'm trying to find my writing pen. Hang on. Let me get all my stuff out. I actually had to go. Have any of you guys ever done an MRI before? Where you're in a tube and they take all kinds of pictures? Well, that's where I was this morning. And because of our, oh my gosh, where is it? Because of our family history of aneurysms, I was forced as the mom to go get it done. It was loud. It's so loud when you do it. I am so sorry. I thought I grabbed my pen out and I didn't. Give me 1 second. There it is. Okay, now I got it. Anyway, so that's why I'm a little discombobulated this morning. I'm trying to remember where all my stuff is. So, okay, here we go. So the reason for factoring is what we're doing is we're finding where our, let's give them the right thing here, where our graph crosses the x-axis. That's what we're finding. And so it's super important to know how to factor. It makes life so much easier. So when we're looking at this, what I'm finding are these 2 points. Okay, so factoring can only happen when we are working with what's called a quadratic equation. And a quadratic equation looks like that. It's a parabola. So it opens up, or I can flip it over and it'll open down. Either way it works. But this is the same basic shape. And a parabola is what they call symmetrical across the vertex. So this is what's called the axis of symmetry. It's a mirror image. And so a parabola will never have a look where it looks like this. So if I have my graph here, a parabola will never look offset. It won't be like this. See how it's offset? It will always be symmetrical on both sides of that axis of symmetry, that line, that vertical, the invisible vertical line that goes through the vertex, which is this point down here. Okay, so it won't be skewed anyway, right or left. A parabola always has this symmetrical shape. What we're doing when we're factoring is we are finding the values where our parabola crosses the x-axis. And so what we're going to do, so this is kind of this is, how you guys are in a Coreq class. Coreq meaning we're embedding developmental topics into the college level class. So this is one of those developmental topics. It's a topic that you learned at some point in junior high or high school, and you may or may not have continued with your skills. So if you took 410 in college, if you took math 410, you got just the very beginning of factoring. But in high school, if you took pre-algebra or algebra 1, you learned how to factor. So you got to go back to those days, and usually that's 8th grade, 9th grade, and 10th grade is when you see those topics. So with factoring, this is what we're going for. We're looking for where do these points cross, or where does the parabola cross the x-axis? That's what we're looking for. In business, what those points are called the break-even points. And we'll get more into that when we get into the quadratic function chapter, which is 2.3. Okay, so these are called the break-even points. And what that means is if I have a graph, and I have a revenue function that looks like this, and I have a cost function that looks like this, these points right here are my x-intercepts, okay? Because if I bring these down, they cross the x-axis right here. These are my break-even points. This is where the revenue equals the cost, okay? So above the cost line is my profit. Below the cost line is my loss. And so in business, these break-even points are going to be super important, because that tells us where does the profit start and where does the profit end. So the profit starts at this point right here, and it covers all of this area underneath the revenue. So under the revenue and above the cost, this is our profit area. So profit will start and stop in some interval. We have to figure out what that interval is and be able to work within that to keep our company in a profitable situation. Okay, so that's where we're going with it. That's the understanding of, okay, I have to know how to do this so I can get to this point. Okay, so now let's get back to the factoring. Okay, so there are 6 different types of factoring techniques. And again, the biggest challenge is, do you know which is which? So, or do you know how to, or which technique are you going to use? So the first technique is called GCF, or greatest common factor. Okay, and this is your hint. You're going to look for something in common in every term. Common meaning it has the same factor in it or the same value in it. So when you look at A, you have 3x squared plus 6x. Okay, you can see both terms, so each of these are a term. Both terms have an x in it, but they also have the value 3. And when I say in it, what I'm thinking of is I'm dividing. So I'm literally dividing both of these by the same term. This is the greatest common factor. So when you answer this question, you're going to have what's in common on the outside of the parentheses, and then you're literally dividing. So 3x squared divided by 3x is just x. And the way I get that is 3 divided by 3 is 1. X squared divided by x is just x. Or you can look at it this way. I have 2 x's on top, and I take 1 x off of the bottom. And what do I have left? I have 1 x left. Okay? And then I jump over here, and I'm going to do the same thing. 6x divided by 3x is just 2. So 6 divided by 3 is 2, and the x's cancel each other. Okay? Now, to check it, you should never get these wrong, ever, because you should always be willing to double check that you did it correctly. So to check it, I'm just going to multiply back through, right? I'm going to go 3x times x is 3x squared. That works. Then I'm going to go 3x times 2 is 6x, and that works. So I know that this is correct because when I check it, I get back to the original function. Okay, so you should never get these wrong. Always be willing to check it. Now, you don't even have to write anything down. You can just go 3x times x is 3x squared. 3x times 2 is 6x. I know I did it correctly. Okay, but the key to this is looking at every single term. So we're going to look at every single term, and we're going to figure out, all right, what's in common? So someone give me what's in common number-wise, just the coefficient in front.
5.
Good. What else is in common?
Is it X?
Perfect. Right. So all 3 of these have an X. All 3 of these have a 5 that I can divide out of it. And then if you notice on A, I ended up with a binomial within parentheses. On B, I'm going to end up with a trinomial inside the parentheses. So however many terms I have determines how many terms I'm going to have on the inside. Okay, so now I'm going to divide. So 10x divided by 5x is 2x squared. Negative 25x divided by 5x is a negative 5x. And then 5x divided by 5x is plus 1. So notice I'm never going to stop until I have 3 terms inside the parentheses because I started with 3 terms. Okay. And then to check it, I'm going to always check it in a different color. If I check it, 5x times 2x squared is 10x cubed. 5x times negative 5x is negative 25x squared. And 5x times 1 is 5x. So you can see I'm right back to where I started. So all of this checks. Okay, so what happens is those are my factors. So remember, the term factor means what did you multiply together to get the original function or expression. Okay, so my factors are 5x and 2x squared minus 5x plus 1. That's the answer to, or the factors to B. Okay, let's try one more. C is 100x to the 5th plus 25x to the 4th. What's in common? Anybody?
The 25 and x to the 4th.
Perfect. So 25x to the 4th is in common with both, which means when I say in common, that means I can divide 25x to the 4th out of both of those. So Ava, can you explain why you did x to the fourth and not x to the fifth?
Because you can only take away what you have, and you have only x to the fourth on the 25.
Okay, and if you think of it the opposite way, if I wanted to take out x to the fifth, I could do it out of my 100 x to the fifth, but I can't take x to the fifth out of x to the fourth, right? So whenever you're dividing out, you pick the lowest exponent. Always pick the lowest exponent. Okay, so 100 divided by 25 is 4.
Was it frozen for y'all too?
Yeah.
Yeah. Any questions about factoring? I'm sure you guys have gone over that part in high school. We'll be back in a little bit.
Okay. I just realized I was on mute. So go ahead and pick any two of those four, and then in the chat, type the number that you did, and then the answer that you got.
For number 3,
Either 3, 4, 5, or 6. You pick. Sophia, on the 1, you said you don't understand why I put the 1. Well, when you're dividing anything over itself, so if I did, let me get this out of the way. If I did, so what I did is I did 5x divided by 5x. That equals 1. So anytime you're dividing out the exact same thing, so like down here, 25x to the 5th or to the 4th, I divided by 25x to the 4th, and that also equals 1.
Okay, so if we didn't put the 1, it would be counted wrong.
Correct.
Right?
Yep. And the way that you double check is, do you see on on B, there's 3 terms, right? Your answer in the parentheses has to have 3 terms. That's how you know that that 1 needs to be there. Because when you check it, if you do 5x times 1, you have to have 5x. That's part of what you started with. So that's why the 1 has to be there. Okay, and then same thing on C, when I divided 25x to the 4th by 25x to the 4th, I end up with a 1 here, right? And then when I check it, I have to have 2 terms inside the parentheses because I started with 2 terms. So whatever you start with, that's how many terms you should have in the parentheses.
Okay, thank you.
Mhm. Are you guys getting rain down there?
Yeah.
Are you? It is dumping here right now.
It just started raining here.
I love it. I heard on the news that Thursday we're supposed to get like 4 inches of rain up here, which is great because our river, the Guadalupe, is not doing well. Okay, I got 1 answer so far.
I'm sorry, my internet like froze out. Is there a question we're supposed to be solving?
Yeah, so pick from the questions 3, 4, 5, or 6. Just pick 2 of them.
Mhm.
Any 2, doesn't matter, and then put the number that you did and then your answer
Okay.
in
thank you.
the chat. Mhm. Okay, Santiago and Dylan, good on number 4. Good, Bo. Good yes, good answer. And then pick 1 more to do.
I have a quick question.
Sure.
I was trying to do 5, and I had like 2 ways of thinking it would work. And I was
Okay.
wondering, so I obviously it was 6x is a like factor or whatever.
Okay,
But
so I'll stop you there. Does
Mhm.
the 30 have an X?
Oh, there it is. Okay, yeah, that's what I
That's
was. Yeah, okay.
Yeah.
Never mind.
why. You are on the right track, but every single term has to have the same value or same term.
Yeah, you're right.
Okay, good, Douglas. Number 3 is good. Number 6. Good. Good, Isabel. Let's see, Orlin, I missed yours. Oh, I see what you're saying. Gotcha. So number 3 is good, and number 6 is good. Yes. 6. Good, Sophia. Sophia, there's one thing that needs to be fixed on number 6 on yours. So when you look at 8x cubed, 12x squared, and negative 10x, there's something else besides the 2 that's in common. Good, Isabel. And 5. Good, Ava, on number 5. There it is, Sophia, good. And Anwar, you did number 4. Good. Anissa, number 3, good. Okay, so now I'm going to start putting the answers here so that everybody can see them. And then again, just showing you, so this is the correct answer, right? I'm gonna box in the correct answer and I'm gonna put in yellow the check. And again, just do a mental check. I'm just writing it down so you can see how I'm doing the work, but just do a mental check. 3x squared times 5 is 15x squared. I'm good there. 3x squared times a negative 7x squared is a negative 21x. Okay, this is a great example. 3x squared times negative 7x squared is negative 21x to the 4th. Do you see how I should have 5 there? So this is why you always check, because you can inadvertently write the wrong exponent. Now I have x to the 5th. So just do a quick check. Always do a quick check and make sure that what you end up with when you multiply these is always what you started with, right? And you can just do a mental check. I'm just writing it so you can see how I'm checking it, okay? All right, on number 4, we got 6x to the 4th. What's left is, remember, you're dividing. Good, okay. So this is the correct answer. And then to check it, I have 24x to the 4th plus 30x to the 7th. That checks. Okay, and again, I'm going right back to the beginning. So these are my factors. These right here are the 2 factors that when I multiply them together, I get what I started with. Okay, and then the last 2. And if you have questions, stop me. I'm assuming since we're moving on that you guys got this. So we have, when I divide 6 out, I have x squared left. When I divide 6 out, I get 4x. And when I divide 6 out, I get 5. And then to check it, 6x squared minus 24x plus 30. I'm good to go. So while I'm finishing this, any questions on these? You feel pretty good about it?
I have a question.
Sure.
So why, I would think you would just have to put this 6 parentheses x minus 4x. Why is it x squared?
Because I'm just dividing off a 6 here.
Mhm.
I'm not dividing off an x because the 30 doesn't have an x. Right? So
Mhm.
all I can take out of, remember, it's got to be out of every single term. I can take a 6 out, but I can't take an x out.
Thank you.
Yeah, it's got to be every single one. Okay, we ready to move on? So this is called greatest common factor. Now, greatest common factor can be used with all of the other techniques. So you always, always, always look first to see if they have anything in common. If there's something in common, you factor that out, and then you're going to use the technique to factor again. So sometimes you have to factor again, sometimes you don't. But the greatest common factor can be used with all of the other techniques, and I'll show you what how that works. Okay. All right. So factoring by grouping. Factoring by grouping happens when you have 4 terms. That's the only time you're going to use factoring by grouping. Okay. So in your notes, factoring by grouping equals 4 terms. Okay. The beauty of this, though, is when I do factoring by grouping, I'm using the GCF again. And then do it again. So I'm actually doing the GCF twice. Okay. So when I mean by factoring by grouping, I have 4 terms, 1, 2, 3, 4. I'm going to group the first 2 and group the second 2. Okay. Because as you can see, if I look at all 4 terms, there is nothing in common in all 4 terms. But there is something in common in the first two, and there is something common in the second two. Okay, now you can rearrange them. That's completely okay. I can rearrange them and get grouping where the first two have a common value and the second two have a common value. Okay, just make sure you bring along the sign. All right. So when you do factoring by grouping, I'm going to group the first two. So what's in common with the first two?
3,
What else?
3x, sorry.
3x. There we go. Okay, so look at your numbers and then look at the variables. So we have a 3x in common. So just like what we did before, what's left is I have x minus 1. That's what's in common. So I'm going to do this with different colors because it'll help, I think. Okay, so now I'm going to jump to the second set. So in the second set, what's in common?
2.
Okay, and I'm going to use this symbol. Whatever that symbol is, that's what I'm using here. So that middle symbol is going to come down here. So plus 2. And then what's left is when I divide off a 2, I end up with x. Oh, I wanted the black, not the, hang on. I'm trying to use 2 different colors and keep it consistent. So what's left? 2x divided by 2 is x. Negative 2 divided by 2 is a negative 1. Did you notice that these are the same? If those are ever different, you did something wrong. Okay, sometimes it's a sign issue, sometimes it's just a dividing issue. Okay, so these 2 sets of parentheses should always, always, always be the same. And then what I'm going to do is I'm going to factor again. So what's in common between these 2 terms, this term and this term, is an x minus 1. And what's left is the 3x plus 2. And that goes in the second set of parentheses. So you're doing GCF actually 3 times. You're doing GCF with the first 2 terms, GCF with the second 2 terms, and then GCF with the whole thing. Okay, and that's why these 2 sets of parentheses have to be the same. The 2 underlined green, they have to be the same so that you have something to pull out. And then what's left is this term and this term. So that's why you have to have this symbol, because you have to have something that connects the 3x with the 2. And that's factoring by grouping. So again, what you have is 2 sets of parentheses. They're both factors because we're multiplying those together. Okay, so if you remember, go back to the polynomial section to check this. If I was going to check it, I would just do FOIL, right? I go x times 3x is 3x squared. X times 2, that's your outside. Negative 1 times 3x, that's your inside. And negative 1 times 2, that is your, oh my gosh, that's your last. So first, outside, inside, last. That's why we call it FOIL. And you can see they're in the wrong order, right? But the signs are all there. If I rearranged it, I'd have 3x squared minus 3x plus 2x minus 2. Exactly what I started with. So it checks. Okay, any questions? That's called factoring by grouping, because you're grouping the first 2 and grouping the second.
So I understand like the majority of it, finding like the GCF and everything of both different groups.
Okay.
But that last line, the x minus 1, do they cancel out?
Well, they don't cancel. What you're doing, just like when you factored a 3x out of the 3x squared and the negative 3x, what's left was x minus 1. And it's just division, right? So if you look at the 3x times x minus 1 plus 2 times x minus 1, what's in common is the x minus 1.
Okay, so you
Okay.
only have to multiply x minus one time, not both.
Correct. Yes.
Okay.
Yeah. Just like when you
That's where I
factored
got
out.
lost.
Okay. Yeah. Yeah. Just like when you factored out the 3x, you don't do 3x times 3x. You just factor out 1 3x, and then what's left goes on the inside. Same thing.
Okay.
I'm factoring out 1 x minus 1, and what's left goes in the other set of parentheses.
Okay.
Okay. All right, let's try it again. So B, I factor the first group and I factor the second group. So in the first group, what's my common value in the first two?
X.
Perfect. And then what's left is x plus y. And then I bring down this symbol, so plus, and then what's common in the second group is y. Thank you, Bo. And then what's left is x plus y. And again, as soon as I see that these are the same, I'm good to go. I know I've done it correctly. So I factor out what's in common, which is x plus y. And what's left is another x plus y. So this, let's see if I can, I don't want to put in too many marks. I don't want to confuse you guys. So this and this gets pulled out as 1. And then what's left goes here. Okay. Questions, comments?
Can you just write it as x plus y squared?
Yes, and we'll get to that later, but this is just the factoring by grouping. But yes, you could. Because that's a whole nother technique, if you will, of factoring. All right, here we go. Factor group the first two, group the second two. I'm going to do C up here. Okay, so what's in common?
2x.
Thank you. See, Santiago, how important it is for you to be here. You answer. I love it. Okay, and then what's left is 3x minus 1. So, Sophia, just like last time, I did 2x divided by 2x, and I get 1. Also, I'm factoring 2 terms. I have to have 2 terms in my set of parentheses. So I'm going to bring this symbol. No, that didn't have it. And then what's left? So what's in common with the second two?
Y.
Perfect. And then what's left is exactly the same thing. So again, if you ever come up with the wrong set of parentheses, or these are different, you got to stop and figure out why are they different. Maybe you need to rearrange the factors. Sometimes that will help if you rearrange the factors. Okay, so what's in common? We have 3x minus 1. And then what's left is 2x plus y. Okay. And then again, I could FOIL it through just to double check. And if I do this mentally, watch how I can do this mentally. 3x times 2x is 6x squared. I'm good. 3x times y is 3xy. I'm good there. -1 times 2x. I'm good there. And -1 times y is -y. I'm good there. So it checks. So I know that that is the correct answer. That's my correct answer. This is my correct answer. Okay. All right. Now you try. There's 4. Pick any 4. So again, in the answer or in the chat, put the number that you picked and your answer. And just pick any two. Good, Ava. Okay, and then on number 10. Okay, so Santiago, make sure, do you see how what's in your parentheses is not the same? And which number is that? Which one did you do? Is that number 10?
Yeah, it's 10.
Okay, so do you see how what's in the parentheses is not the same? So there's something off. So go back to the first two terms, the 30x squared and the 9xy. And what do you have in common there?
We'll have 3.
Okay, and an x, right? 3x. So it looks like that part's right, because when you multiply what you have back through, you have 3x times 10x is 30x squared, and you have 3x times 3y is 9xy. So you're good on that first one. But then do you see how the middle sign is a negative?
Yeah.
Okay, so that it, instead of +2, it should be -2. And then when you divide 2 out of 20x, you're going to end up with 10x. But you remember you're dividing by a -2 because that negative sign needs to come with it.
Okay.
Okay.
All right.
So the
Yeah.
first part is right, but the second part, the 2 times 3x minus 2 is incorrect. So go back to that part. Okay, good, Isabel, on number 8. Okay, number 7. Okay, so Sophia, so you're doing the same thing. Do you see how what's in the parentheses is not the same? For number 7. So your sets of parentheses have to be the same. So if it looks like the 5x times 3x plus 4 is correct. So look at that second set, the 6yz and the 8y. 2 is in common, but there's a variable in common also. And that in the first set of parentheses, that 3x should be 3z, not 3x. Okay, so you're back on track, Santiago. So now what you have, what's in common between those two sets of terms?
A 2.
No, do you see how you have 10x plus 3y and 10x plus 3y in the second set of parentheses?
Yeah.
Yeah, so that's what's in common. So now pull one of those out, and then what's left is the 3x minus 2.
All right. All right. I
Okay.
just thought I got it completely wrong. Yeah.
No, it's not, you're not wrong. You just need to do that very last step.
Okay.
Okay, and then Anissa, number 7. Perfect, good. And then Anwar, perfect. Mia, number 9. Okay, let's see. So there's something wrong with that x minus 2x. It might be a variable. So go back to that first set of parentheses. Because if you did FOIL on that, you'd end up with 3x squared. So you're missing a y someplace. Okay, Douglas. That looks good. Number 7. Okay, I see what you're doing. And then Dylan, number 9. Okay, so Dylan, if you were to multiply that back through and did FOIL on your answer, would you get the 3x squared y minus 6x squared minus 3xy plus 6x? So multiply that back through and see if you'll get that. If you don't, then you're missing some values. Okay, so Sophia, on yours, you have the 3z plus 4, which is correct. So now factor that out. Remember, you have to go back to factoring that out so that you have what's in common. Okay, so let me start writing here, just so we can double check. I'm starting to lose it all. There's so many answers coming in. I'm so happy. All right, so we're gonna group and group. So what's in common on number 7 is 5x. What's left? Oh, let me do this color-wise. I think that helps. Okay, so what's left is 3z plus 4. And then I'm going to use this middle symbol plus, and then what's in common here is 2y. And then what's left is 3z plus 4. So we have, these are the same, and that's why I'm saying those have to be the same, because when they're the same, then we can take the last step. Okay, so let me double check everyone that's done number 7. 3x plus 4, 5x plus 2y. Okay, so Brianna, let's look at yours. So you have 15xz, which you're good there. 20x, 6yz, and 8y. Okay, do I have the, oh, I'm the one who wrote the wrong variable, sorry. Z, I had it right in the next step before, there we go. Okay, so everyone that did number 7, you're good?
Yeah.
Okay. So don't forget this step right here, big step, right? Every time you factor, you should never have a plus sign outside the parentheses, right? It should be two complete parentheses that you're multiplying together. So when you're doing factoring by grouping, which means you start with 4 terms, you should always end up with 2 binomials every time. Okay. All right. So number 8. We have 6x squared. And then we have 4x minus 7. Plus, and then I have 5. Oops. Times 4x minus 7. These are the same. So what's left? I'm going to factor out the 4x minus 7, and then what's left is the 6x squared plus 5. Okay, again, 2 sets of parentheses. Everyone who did 8, you're good? Brianna, there you go. Oh, I didn't see who else did number 8. Okay, all right, so here we go. Factoring, I'm going to factor out a 3x squared. And this, I can honestly tell you, this whole factoring idea only becomes comfortable when you do them over and over and over and over again. So on this, this week's homework, I am opening it up so that you can have unlimited access to it. All right, so what that means is you need to start today and do them over and over and over and over and over again, because that's how you're not going to do, oh, this section is GCF, this section is factoring by grouping, this section is trinomials. You have to be able to recognize it with all of them intermingled, and you just have to work at it. And I'm trying to talk and do this at the same time, so double check, make sure I'm doing this right. So when I check, I get 3x squared y. I'm good there. Y times negative 3x is a negative 3xy. I'm good there. Negative 2 times 3x squared is negative 6x squared, and negative 2 times negative 3x is a positive 6x. So I'm good with all of those. Okay, and then the last one, I'm going to factor out a 3x. And I end up with 10x plus 3y. And then my second set, remember you're using that same sign. So I'm factoring out a negative 2. And what's left? So 20x divided, or negative 20x divided by negative 2 is a positive 10x. And then negative 6y divided by negative 2 is a positive 3y. So again, that's why you always want to double check that these are the same. And it'll keep you honest. Because if the first one has a plus sign, the second one has to have a plus sign. So whenever there's a negative in the middle that we're going to use to bring down, that is where a lot of people get caught, is because they forget that you're factoring out or dividing out a negative, which changes the signs. So I have 10x plus 3y factored out, and what's left is the 3x minus 2. Okay? All right, so Orlin, where'd you get the on number 7? Did you do number 7 and you called it number 1? Is that the one that you're doing, Orlin? Oh, I see what you're doing, number 9. So you took this and factored out a 3x. Okay.
Yeah.
Okay. All right. And that works. So what you did is you factored out the 3x first and then factored it again, which totally works. That's that combination of GCF. Good job.
So I wasn't wrong because I was like
No,
looking at your answer.
you that was 100% right. So here's what Orlin did on his. He saw that 3x squared and 3x has something in common. So he can factor out a 3x and end up with x minus 1. And so the simplified answer would be these, you know, in this order. And it doesn't have to, because it's all multiplication, you can have them in different order. The other way to look at that is I could see from number 9, I can take out a 3x out of every single term. And that's that greatest common factor can be combined with any of the other ones. Okay. All right. We're going to stop there for right now. It's 12:03. Go ahead and take your break. And when we come back, we'll do all the other 4 techniques, and they all kind of fit together. Okay. So I will see you at 10:05 after, at 12:15. Like I said, you'll have lots and lots of practice. So in fact, while I'm waiting for a few more people to come in, I'm going to go into our class. I know you guys can't see this, so that's all right. And make sure that it's at unlimited access, because I want to make sure that you have plenty of practice. Okay, all right, so I'm not limiting the number of attempts on homework 10 or 11. So because 11 is how we find the x-intercepts. So we'll get to that in a minute. Okay, so let me get back to sharing. And Franco, if you have any tips on factoring, because I know there's different ways to do it, please jump in anytime. I don't have a problem with that at all. If you ever are like, oh, there's another way to do it, because there's, like I said, there's different ways to do factoring, and different techniques, especially with the trinomials. So in fact, Franco, how did you learn? Well, let me get through this one, and then when I get to the AC method, because I know the AC method, there's a couple different ways to do it. Okay, so with this one, so now we've kind of moved on from the 4-term polynomial, and now we're in a trinomial. So remember, a trinomial has 3 parts to it, and because it's a quadratic, the exponent that's highest is going to be squared. So you notice that on A, B, and C, every first term is x squared. And make sure that when you're doing these, that it's in that order. In other words, you don't want to get to the point, get this out of the way, where let's say you had 3x plus x squared minus 2. Okay, if you ever see something that's out of order, this is not in descending order. You want to rearrange it so that it is in descending order. So we have 2 is our highest, and then remember, this is x to the first, and then this one is actually x to the 0 power, because anything to the 0 power is just 1. So anytime you have to rearrange it, do it. You always want your x squared to be in the front. Okay. Oops. So when there's 2 different trinomial type factoring techniques. This one is when the a value is 1. And when I say a is the first number in front of your x squared. So if there's no number there, it is a 1. Okay, so this technique works when it's x squared by itself, there's a 1 in front of it. All right, now the way I learned it is I create a little x, a big X shape. The third term goes in the top, and the middle term goes in the bottom. Okay, so the idea is, what are the factors of 6 that when I add them, I get -5? Okay, so factors again are, what are the numbers that I'm multiplying together? So my factors are 1 and 6, 2 and 3. Okay, these are the only factors of 6 that when I multiply them, I get 6. Now I'm going to use these same factors. When I add them, I'm going to get a -5. Now the positives and negatives matter. All right, So the only way to get a positive 6 is either 1 times 6 or -1 times -6. I still get positive 6, right? Or 2 times 3 or -2 times -3 is also a positive 6. Now, when I look at these factors, if I'm going to add them to get -5, so I'm multiplying to get 6 and I'm adding to get -5. Well, I can see that they have to be a -2 and a -3. So my factors have to be both negative, but the parameters have to, the two factors have to answer two questions. Can I multiply these to get positive 6, and can I add them to get -5? So the signs are going to be where it's going to trip you up. Okay, finding the factors is easy, but when I add them, do I get that -5? All right, now this is one way to do this. All right, another way is you can write it out as factors of 6 and then the sum of -5. You can do it this way too. So factors of 6 okay, we already know what the factors are. So 1 plus 6 is 7, 2 plus 3 is 5, -1 times or plus -6 is -7, and -2 times -3 is -5. So this tells me that my factors are -2 and -3. So you need to find a technique that works for you. Okay, if you can just do it in your head, good for you. That's awesome. But if you need to write it down, these are two techniques that you can use. Okay, so from there, you're going to write 2 sets of parentheses. Right, there's my 2 factors. The only way to get x squared is x times x. That sits in the first position. And then I use my factors, -2, -3. And I'm done. That's it. So find your factors. The only way to get x squared is x times x. And then plug your factors in and you're good to go. Now, you can also, again, double check it. Use FOIL. X times x is x squared. X times -3 is -3x. -2 times x is -2x. And -2 times -3 is a positive 6. When I put this together, right, you're adding like terms. You see, I am right back to where I started. Okay, so again, this is the check. Did you do it correctly? Once I see I did it correctly, this is my answer. Those are my factors. That when I multiply them together, I get x squared minus 5x plus 6. Okay. Franco, did you have another technique for this particular kind, or how did you learn it?
I kind of learned it the way you did it second, the factors of 6, but instead I just would do a T-chart and then do it that way. I did learn another way from another professor though. It's called like the box method.
Okay. So
And
this
it's
is
kind of
your
like,
T-chart.
yeah.
Okay,
Well,
I haven't used the box method, so you might have to walk me through that one.
so the box method, you make it kind of like a Punnett square. Yeah, you can do it that way too. And then, so on the top left always goes the x squared. And then on the bottom right, on the bottom right is just the number.
In the box itself, so this should go here.
Mm-hmm.
Okay.
And then on the bottom right is the number, which would have been, I think, 6.
6, okay.
And then you put the factors that would go into it. So you could put like a 2x on the top right, and then like a 3x on the bottom left.
Okay. And they should both be negative.
Yeah.
Okay.
And then on the outside, you would have like, now outside of the square, it's like this is where it becomes a Punnett square, where it's like, what do you multiply on like the left column? what do you multiply down? And so it'd be an X on the outside. And then the
Okay,
next one would be, what do you multiply by that one? And it would be, oh, like a 2. And then
okay,
the other one would be like a 3. So you're trying to do it that way.
okay, okay. So this one is, I mean, it's just because I'm not comfortable with it. So if, let's see. Has anyone else?
I've done it that way.
Okay, so the 3 goes here and the
Mhm.
X goes here, right?
Yeah. And then you would
Okay.
have the signs as well. Yeah. You have
Okay,
the
all right.
signs.
So if you take an X out of the top 2, the X squared minus 2X, you get
Mhm.
X minus 2. If you take a 3 out, you have X minus 2. Correct? Okay.
Yeah, I personally don't use that method, but when I tutored other classes, a lot of students seem to like it. I usually use just like the way you did the factors of 6, but I
Yeah.
usually just do it as like a T-chart instead.
Okay.
That's how I
So
learned it.
tell me how you set up your T chart. What did you do?
So at the top of the T, you have 6. And then you would
Okay.
just do on the, well, yeah. So it's like a T chart starting underneath. So it's like a capital T.
Gotcha.
And so then the 6 is on the top, and then you would just do the factors on the sides. Like, yeah, 6 and 1 and 2 and 3.
Okay.
And then I usually put like an equal sign to the right, and then it would be like what the added together equals,
Okay.
and then go from there. And that's how I do it.
Okay. Okay. So this is the multiplied and this is the
Mhm.
added. And just so you know, don't change your technique. If you already have a technique that works for you, don't change it on my account. You do what works best for you. There's just several different ways to do it. And so that's why I want to make sure that you have all the different ways that you can do it. And then you pick one that works for you. Okay. And you stick with it. Don't try to go 5 different methods. You pick a method and you stick with it. Okay. All right. So I'm just going to stick with the method that I like. Right. So so what I say is the C. So remember, you have ax squared plus bx plus c. The a, b, and c are your coefficients, the numbers in front. Okay. And that's got to be in that order. So what do you multiply to get 30 and add to get 13? So you can do all of them if you need to. And 6 and 5, 5 and 6. But what's going to happen is the more you do this, the faster you're going to get. Okay. Now, again, the signs matter, right? So if I want a positive 30, I need them both positive or both negative. Well, there's no negative in the bottom. So I don't have to worry about that. So 1 and 30 is 31. 2 and 15 is 17. 3 and 10 is 13. There's my answer right there. Okay, so I set up 2 sets of parentheses. X squared is always x and x, plus 3, plus 10. And it doesn't matter what order. I could have done plus 10, plus 3. It doesn't matter. Okay. And I'm done. That's it. If I did the, let's see, the other method, factors of 30, sum of 13. So I could do the exact same thing. So 1 times 30 is 31. 2 times 15 is 17. 3 times 10. Hopefully you guys are catching this. I'm multiplying and then I'm adding. I just realized what I was doing. I'm talking out loud and just doing it in my head. Okay, so factors of 30 are here. When I add those factors, this is what I get. So the 3 and 10 are the only ones that work, that when I add, I get 13. Okay, all right, last one. I got to move. So negative 45, negative 4. Okay, so factors of negative 45. So now I have a negative. What that tells me when I multiply is one of them has to be positive and one of them has to be negative. Here's the trick. If my bottom number is negative, my bigger number has to be negative. That's how you match it. 45 is 3 and 15. Bigger number has to be negative because my sum is negative. And then 5 and 9, bigger number has to be negative. So you can see right away when I add them, I get a negative 45, a negative 12, and a negative 4. So these are my factors. So it's going to be plus 5 minus 9. So that's why the signs are super important. Always notice the signs. Okay, and then again, you can use FOIL, multiply it out, and it will take you back to the original function. Okay, so any questions on that?
No.
Okay, now you try. Just pick one, just to save time. Just pick one. 17, 18, 19, or 20. Pick one and give me an answer. And then put it in the chat. I just looked at my rain gauge. We have 3/4 of an inch since this morning. It's so nice. It's going to be so green. All right, to save time. So number 17, Sophia, 10. Okay, so look at your signs though. Do you see when you add, it's got to be a positive 3. If you added -5 and 2, you'd get -3. So make sure that you're matching your sign with that middle term. And then Isabel, you're perfect. Good. And Santiago, number 18. Good.
Miss Manchester, what did you
Yes,
mean by it would have to be -3?
Well, you have it as an, so let's see, let me go back to it. So do you see when you have x plus 2 and x minus 5? So when you multiply that, you do get a -10, but add, what's 2 plus a -5?
-3, yeah.
-3, and you want a positive 3.
Oh, okay. Yeah.
Okay, so that's where you got to watch your signs. And that's why I was saying, whatever this number is down here, if it's positive, your bigger numbers have to be positive. Because when you add, you give it the sign of the larger number. Okay, so that means the smaller numbers on number 17 have to be negative. So it's got to be -2, positive 15, or positive 5, excuse me.
Thank you.
Yeah, so always watch those signs. So like on 18, the middle number is negative. So that means my bigger numbers have to be negative. So the only thing that could be is the 3 and -5. So x plus 3, x minus 5. And then here we have 35. Oh, you guys can't do 20 or 19. Oh, yes, you can. Okay, so this is the example. Here's an example of GCF with it. So on number 19, I noticed nobody's tried number 19. Let me see if anyone tried it. 19, no. Oh, Ava, you did. Very good. Okay, so number 19, you always look and go, all right, what's in common? So number 19, you have a 7 in common. So when you divide out a 7, you end up with a trinomial. And now you take that trinomial and you can factor it, right? So now it's a 2-step. We factored out a 7, that's greatest common factor, and now we're going to factor the trinomial. So for this one, it's 7 times x minus 5, x minus 1, because I multiply to get positive 5, I add to get a negative 6. Well, the only way to get a positive 5 is they're both negative. The only way to get a negative 6 is negative 5 plus a negative 1. So this one has 3 parts to it, but they're all factors. 7 times x minus 5 times x minus 1. And then same thing with number 20. You can factor out a 3. And then what do you multiply to get negative 8? Add to get 2. So now with a negative multiplication, one of them has to be negative. Okay, so since my middle term is positive, that means my smaller values have to be negative, or the bigger number matches the sign of the middle term. So with this one, it's going to be 3 times x plus 4, x minus 2, because 4 plus a negative 2 is a positive 2. Okay. All right. Let me see which ones I have. Okay. So we're probably not going to get through all of this today, but we'll be able to finish it and do the next section, because the next section is just this and then solving for x. So it's just one more step is all. We're just going to add another layer to it. So you'll be okay. So what I would do is on homework, what is it? Homework 10 is all just factoring. Just jump in and do as many as you possibly can with the techniques that we've used. Okay, so this one is called the AC method. And this is where your A value is not equal to 1. Okay, so that's how you know you have an AC method. So the A value is 3 on this one, 5 on this one, and 2 on this one. Okay, so the technique is actually very similar to the trinomial one where A does equal 1, with one little twist to it. So what you're going to do when you're doing the AC method, you're literally multiplying A times C. Okay, this is one technique. You're multiplying A times C. Then what you're doing is you're turning your trinomial into a 4-term polynomial to use factoring by grouping. So what we're doing is we're adding a layer to it. This is going to be the one that has the most layers to it. And we're turning a trinomial into a 4-term polynomial. Okay, so let me show you how that's done. So first thing I'm going to do, and I just use this same technique. Okay, so A times C goes in the top. So 3 times negative 2 is negative 6 goes in the top. And this is a B, not a 6. This is a B. And then the B goes in the bottom. So in this case, right, there's a negative 1. Remember, it's an invisible 1 right there. So negative 1 goes in the bottom. Okay, so now you ask yourself the exact same thing. How do I multiply to get negative 6 and add those same terms to get negative 1? So again, the factors of 6 are 1 and 6, 2 and 3. One of them has to be negative, because that's the only way to get a negative factor or negative product. And when I add them, the bigger number has to be negative. So if I put my negatives here, negative 6 plus 1 is negative 5. 2 plus a negative 3 is negative 1. So these are my factors. Okay, so this is the step that most people miss. what we're going to do is we are going to explode or rename this middle term using these factors. So I'm going to rewrite 3x squared plus 2x minus 3x minus 2. Okay, so now I've taken a 3-term polynomial and I've turned it into a 4-term polynomial. All right, and that you only have to do this with the where a trinomial where the first number is not 1. All right, so now you can see there is a common factor of x here, right? So I could do that. I can do it that way, or I can rearrange this, because remember I said it doesn't matter how I set them up. I just like to put however many terms, the most number of terms in common. Okay, now if you notice, negative 3x plus 2x still equals negative 1x. So I haven't changed the value of it. I've just changed how it looks. That's all I've done. I've just kind of expanded it out so that I can factor it much easier. Okay, so now I'm going to do my factor by grouping. I have this group, what's in common? I end up with 3x. Right back to factoring by grouping. What's left is x minus 1. And then what's in common between these two is plus 2. And then what's left is x minus 1. I'm going to finish over here. So I factor out the x minus 1. And what's left is 3x plus 2. Okay, so those are my factors. If I were to multiply this back through, I would end up with 3x squared minus x minus 2. And you can double check every time and make sure that it's correct. So the biggest key is making sure, I'm going to do it here, that you turn your trinomial into a 4-term polynomial. Turn your trinomial into a 4-term polynomial. And then you can use factoring by grouping, which you already know how to do. Okay, and that's the step that most people miss. This is a very important step when you're doing the AC method. Okay. Let me show you one more, and then Franco, I'm going to ask if you know a different technique, or anybody, if any of you guys learned a different technique, I'm totally okay with that too. All right, so this was A, this is B. So remember, A times C goes in the top, so I have negative 15, and B goes in the bottom, which is negative 14. So I want factors of negative 15. Right? The only way to get negative is one of these factors have to be negative. Well, my bigger number has to be negative because my bottom, the negative 14. Okay, so the only factors that work, that when multiplied, I get negative 15 and added, I get negative 14 is right here. Because this one is negative 2, so that's not going to work. So I'm going to explode this out. I'm just rewriting it. Okay, and I could have done it the opposite. I could have did plus 1x minus 15x. I just saw that the 5 and the 15 have something in common. So now I have a 4-term polynomial. So I factor out a 5x. What's left is x minus 3. What's in common? Now, here's where the trick comes in. I have to have a part to attach to my 5x. I can't just leave it alone. Okay, so when I have something that has nothing in common, the only thing in common is a 1. So I have to factor out a 1. And I end up with x minus 3. Remember, these have to be the same. right? I can't have them different. So I factor out a 1. Now I have something to attach to my 5x, because remember, we're always going to end up with 2 binomials. Okay, always 2 binomials when you're factoring a trinomial. Okay. All right, so Franco, we have about 15 minutes. Do you have a technique, or does anyone have a different technique?
So the way I started doing it, was that I would do my little T-chart, and then after I figure out what factors those would be, then I put it in the box. So I kind of combined the box and the T-chart. So like if we were to do C, you would do 2 times 5, so it'd be 10 at the top of the T-chart, and then you would find the factors of 10 that would make 7. And then from there you would get the 2 and 5.
Okay.
I wish I could like write it out, but
I know. Well, actually, do you want to share your screen?
sure, I
Okay.
can try.
Oh, you know what though? Do you have the OneNote up?
Yes.
If not, because
It
you
might
can.
take me a bit of time though to get it,
Okay.
because I have to pull it
All
up on
right,
my
yeah,
screen.
we're kind of running out of time, so let me go back to my screen here. Okay, so let me see. You had your T-chart, so you did the 10. This out of the way. So this is, oops, that color. Okay, so this is C. So you did your T-chart, and you had 10 on top.
Yeah, and then you
Okay.
would have the factors of 10, which are 1 and 10 and 2 and 5. So then you have to use 2 and 5 to get the 7.
Okay, gotcha.
So we would have a 2x and a 5x, and then I put it in the box. So then in the box you would have 2x squared in the top left, the 5 in the bottom right, and then you would have a 2x and a 5x. And that you kind of just play around with, because you'll figure out which one would be easier to put where, but ultimately it doesn't matter. You can put in either the top right or the bottom left, and you'll kind of work it out from there, and you figure out what factors. And that kind of does the step of factoring instead of having to put the 4 in like in a line, like an equation.
Oh,
You
like
kind
the
of take that
4-term
step
one.
out. Yeah, it kind
Okay.
of does that, and then it takes it out of the spot. Like you
Okay.
don't.
Okay. So
Then
when
you
you say, is this what you mean by a Punnett square?
Well, so
Or
you
no?
know, like how in chemistry you have the Punnett square where it's like, oh, what's the recessive traits and stuff. I always thought of it that way, obviously, because I'm a chemical engineering major, so chemistry is pretty straightforward to me.
Trying to
And it's like
remember what it looks like.
it's just a square like that, and you're fine. It's just like
Okay.
you have 4 things. So then in the top left, you would have the 2x squared. Inside the right
Inside.
above the
Okay.
line. Yeah. And then in the bottom right, you would have the 5.
Okay.
And then in the bottom, like I would put in the bottom left the 2x, and then I would put a 5x in the top right.
Okay.
And then
And we
now,
got that from this.
and we got that from the T chart. And so then now, what would you multiply that first column by, the 2x squared and the 2x? To get those, you would multiply it by a 2x on the
2x.
top. So then, yeah,
Up
you
here.
could, well, on the top, yeah.
Okay.
And then on that top, like the left side right there, you would just put an x, because 2x times x would give you a 2x squared.
Gotcha.
And
Okay.
then what would you multiply by that x to get a 5x, a 5?
Okay.
So then on the top you'd have, yeah, positive 5. And then on the bottom, what would you multiply 2x by to get 2x? And then what would you multiply 5 by to get 5 is just a 1.
Just a 1.
And so then that's how you do it. So those are your 2 factors. And then you put the
Okay. Okay. I see. All right. I gotcha. I haven't seen this technique. That's kind
yeah,
of cool.
I kind of started using it just for the AC method, because a lot of students sometimes forget to put the x's next to the 2 and the 5 when you get the factors. So in doing it with the box, it's easier to remember, and then you can just go from there.
Okay, so really the only difference between this and the first trinomial is splitting this and making sure that you're multiplying the a times c. So remember, we multiply 2 times 5 to get the 10.
Mm-hmm.
And then when you add, you want 7. So that's why we use the 2 and 5. Okay, so this technique, this box, what do you call it? The box technique? Box
Yeah, the
method?
box method.
Okay, the box method keeps you from having to do the 4-term polynomial. Basically. Okay. I like it. I like it. I've not used that one before. Okay, so we're gonna try. These are always the hardest ones. So again, you guys pick a technique that works for you and practice, 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 practice using that technique. If you make mistakes on it, try the other technique, and maybe the other technique will make more sense to you. And I don't care which technique you use. There's another technique called guess and check. I'm not a fan because you're guessing and you're checking and you're guessing and you're checking. Now you'll get better at it the more you do it, and you'll know how to manipulate the numbers better. But yeah, the guess and check, some people learned it that way. So whatever way you learned it, go back to it and see if it works. So I'm going to try your, so go ahead and pick one. Let's just pick one. I'm going to try your box method. Kind of like it. Okay, so when you do this, I'm trying to think this through. When you do this, if I take a 3x out, am I actually factoring, or am I just looking at what does the 2 columns have in common?
It's technically both. So you're looking at what the 2 columns have in common. So right, the first one has a 3x and a 6x squared, but ultimately you are factoring out the 3x because they both have it in common. So you're
Right.
factoring it out, and you're basically, when you get in that 4-term polynomial, like how you have, it's basically doing that instead of writing it as 4 terms and factoring it that way. You kind of see it in a closer
Okay.
way.
Okay. And then going this way, if I do a 2x and a 1.
Yeah.
Okay. All right. So if I did it the other way, wait,
I have a quick question.
go ahead.
So, like, to my understanding with the way the box method work, um, the 3x minus 2 and the 2x minus 1, like, you would multiply it to get the 6x minus the 6x squared. So 3x times 2x is 6x squared, but then
Yes.
it
And
wouldn't
then
work for
3x,
negative 2 and 2x.
and then the 3x plus the negative 2x gives you the gives you the 1x. That's where that comes from.
Yeah, but that's why I don't get how it works with the negative 2 and then the 2x. Because you would,
This negative 2 right here.
yeah.
So I'm factoring out a negative 2.
Yeah.
Yeah.
Right? So that's what's in common.
Well,
Is the
like I
negative.
understand what you're doing. It's just like I don't understand
No,
how
yeah.
it works in
I
the
see
box
what you're
method.
saying. So it should be,
Did I set it up wrong?
well, I'm trying to see, because what he's saying is right, because 2x times 2 isn't negative 2. So one of those has to be like a 1
So
when you do it.
basically with box method, the top numbers have
Uh-huh.
to equal the equation that you're like factoring for. So the 3x minus 2 and the 2x plus 1 has to, when you group them together again, it has to equal 6x squared plus x minus 2. If it doesn't, then that means that you got it wrong.
Okay,
Yeah, so you see how when you did the 3x times the 2x, you got 6x squared, but 2x times a negative 2 doesn't give you negative 2x.
oh, gotcha, okay,
So that's the step right there.
this step right here,
Yeah.
okay. So why is that, why did it work over here, but not here?
When you did it on the one for C, it's because usually you want to do the x's first. So like you'll find that top left corner first, and then from there, that's usually how I would do it, and then you find the other ones. So you're figuring out what you're multiplying by to get what's inside the square. So for the top left on that C one, for the top left, what would you multiply together to get a 2x squared? You would multiply a 2x and an x. And
Okay,
then what would you multiply together to get 5x? You would multiply a 5 and an x. So when you do it on that number 21, what would you multiply 2x by to get negative 2x?
a -1. Right?
Yeah. It would be a
Oh,
negative
gotcha,
1.
gotcha. Okay, I see where you're looking.
But it's still kind of like the part that also is like this negative 2 on the bottom is what's throwing me
Yeah,
off.
that's not working then, huh?
I think you might have to put,
Do I need to switch these two?
oh man. It's
For
been a
number
while.
21, I just put 4 minus 3x.
Because it would be
Okay,
12,
let me go,
right?
let
So
me,
did you get
because
the 12?
is negative,
Did you do the
oh,
A
that's
times
the
C?
problem. I need it to equal 12 here. Right?
Yeah.
That's
Yeah,
the
you
problem.
didn't do the AC part, I think.
That's the problem. Okay. Because here is it equal, on this one, it equals 7x. And that's what we
Mhm.
wanted.
Well,
Okay,
and
so
we
it
also
needs to
did
equal
the A
negative
times
12.
C is 12, and then you needed to equal that 1x. So what are the two terms from 12 that would equal 1x would be 4 and yeah, you can do
Or
it that
negative.
way.
Yeah.
And so those would be the two x's that you use.
Okay, so 4x negative 3x. Okay, gotcha. So now this should be, see, it's always good to learn something new. So this one I'm taking out a 2x
Mm-hmm.
and then 3x here. And this one I'm taking out a 1 and a 2 here.
Yeah.
So 3x times 2x is 6x squared. 3x times -1 is a negative 3x. 2 times 2x is 4x, and 2 times -1 is -2. Okay, now it's working. All right, very good.
Yeah, so you always gotta, the AC part is the part you still have to do. So you do have to do the A times C.
Yeah, so you still have to do that part. Okay. Oh no, what happened? Ah, I don't know what happened. There it is. Wow, that was weird. I hit something very wrong. Okay, so here, I renamed it as 4x minus 3x minus 2. I'm trying to do both techniques, is what I'm attempting to do. Okay, so now what's in common here? I have a 2x and then 3x plus 2. What's in common here? A -1. Okay, you see it? And then I have a 3x plus 2. So my two factors are 3x plus 2 and 2x minus 1. There it is. Okay, we'll work more on that on Thursday. So what I would suggest is go into your My Math Lab homework 10 and do GCF, factor by grouping, which means there's 4 terms, and the 2 trinomials, and do as many as you can. And then we'll jump back in on Thursday. Okay? All right, we're going to stop there, you guys. Have a great night, and I will see you Thursday morning, and it's supposed to be dumping here, so hopefully the internet works. If it doesn't, we'll figure something else out. Okay? All right, have a good night.
I just want to say something real quick.